So in this video, we're going to talk about perimeter and area, specifically on a coordinate grid. But to start off with, I wanted to show you, I took these pictures when I was at Lowe's the other day. I don't know if you can see this, but these were ceiling fans that were for sale. And this ceiling fan was for a large room, which is up to 400 square feet. And then these ceiling fans here were for a small room, which is up to 100 square feet. So I don't know if you know like the square footage of your bedroom or living room or of this classroom that we're in, but if you found the area, you would be able to know which fan to use. So this is an example of when you might actually need to find area if you need to, buy a ceiling fan one day. So for example, in this particular house plan, we've got a living room that's 15 feet by 18 feet, a bedroom that's 8 by 10. So if I wanted to buy a ceiling fan for these rooms, 8 times 10 would be 80 square feet. Which in that case, we would use one of the small room fans because it's up to 100 square feet. Whereas like for the living room, if we do 15 times 18, that is 270 square feet, which would be one of the large room fans because that's up to 400 square feet. Also, I thought I'd mention, I don't know if any of you know a whole lot about Atlanta, but Atlanta has, 285 going around it. And if you're from Atlanta and you're like actually in the city, they call it ITP, which is in the perimeter, which is this. And if you're outside it, like in the suburbs, they call it OTP, or outside the perimeter, which isn't as cool. And the perimeter is literally like the edge of the city, which is kind of like 285. So that's just a reminder of what perimeter is. Perimeter is the sum of all the sides. It's like around the perimeter of your shape. You add up all the sides of the shape. And then here's a few area formulas. These are on your formula sheet, but you really should know these at this point. A triangle is half the base times the height. A rectangle is just base times height or length times width. And a circle is pi r squared. So those are a few common area formulas. Here's a few that are not on your formula sheet that I thought I'd mention. With a parallelogram, it's just like a rectangle. You still just do the base times the height. However, it's not the slant height that you use. A height has to form a right angle with the opposite side. And so the height here would be like straight down, forming a right angle, not the slanted height. And then for a trapezoid, it looks kind of complicated, but it's actually pretty straightforward. A trapezoid is still kind of just the base times the height. The problem is, which base do you use? There's a smaller base and there's a bigger base. And so what you do is you actually just average the two bases. You add them up and divide by 2, and then you do that times the height. And again, the height has to go straight down, perpendicular to the base. All right, let's talk about triangles real quick. Just a reminder, like I've been saying, the height, also known as the altitude. If you ever hear altitude, it just means the height, because like the altitude of a plane is the height of a plane. So the height has to form a right angle. If you have a right triangle, that's pretty handy because then one leg can be the base and the other leg can be the height because it forms a right angle. But if you have a triangle like this, the height, again, it has to form a right angle with the opposite side. I could have made the height right here because that also forms a right angle, or I could have made the height right like this because that also forms a right angle, but whichever one, you just do whatever is easiest. And this particular triangle, which is a very obtuse triangle, it's way over here, and so the height on this one is actually outside the triangle, and that's okay. I could have made this the height, but sometimes it's easier to make the height even be outside the triangle, because do you see how this makes a right angle with this side if I were to continue it? So keep that in mind as we work through some of these problems, but it's got to form a right angle just like you see here. Okay, so let's go through a few on a coordinate grid. This triangle connects these 3 points. What do you think, if I were going to try to find the area here, which side would you use for the base and the height? I could make the height right here and form a right angle. The problem is, if I make this the height, first of all, I don't know exactly where to go. And then second of all, I'm going to have to find this length, which I would have to do distance formula or Pythagorean theorem. It's going to be a lot of work. Instead of doing that, why don't we make this the base? Because first of all, I can just count it. It's 1, 2, 3, 4. And then if this is the base, then this would be the height. And I know for a fact that's a right angle because it's right on the grid lines. So basically, anytime you can use the grid lines to your advantage, try to do that. In this case, that would be the base. This would be the height, 1, 2, 3, 4. And the area of this triangle would be 1/2 times the base times the height. Let's try another one. On this one, which would you use for the base and the height? I'm going to use this one right on the grid line as my base, again, because just the grid line's easier to count, and that would make this the height. So the height would be 2, the base would be 1, 2, 3, 4, 5, 6. Let's try this one. This one's a little weirder. All right. It may be tempting to say, let's make that the height. But again, I don't know exactly where it should land. Like, should it be here? Should it be here? Like, where exactly is a right angle? And then I would have to find these lengths, which is annoying. So what would be easier is, again, if you can ever just use the grid lines, that should be the goal. So if I make this the base, that would work. And if that's the case, then this is the height. Going straight down, forming a right angle with the base. And so that works. The height would be 2, and the base is still just the actual base. Don't like extend it. The base is still just 1, 2, 3. So just kind of twist some things in your mind a bit. Let's try one more. Okay, on this one, none of the sides are actually on a grid line. So that's kind of annoying. But if I ever have a right triangle, then I can just use the side lengths as the base and the height. And this one is a right triangle. I know because this side right here goes down 2/1, so its slope is -2/1. And this side right here goes up 2/1, 2, 3, 4, which simplifies to 1/2. And if you notice, their slopes are opposite reciprocals. If one's positive, the other's negative, and you flip it, which proves that this is a right angle. These two lines are perpendicular to each other. So I actually know that this is a right triangle. And so what I can do is use like one of the sides as the base and the other leg as the height. And that's the hypotenuse, so we're not going to use it. I would still have to do distance formula or Pythagorean theorem to find the length of the base and the length of the height, but I'm not really going to want to just drop a height right here because, again, I don't know exactly where to go. Also, if all else fails and you can't figure out how to find the area by like dropping a height somewhere, here's what you could do. Make a rectangle out of it. And I know the area of the rectangle. It's 24 because this is a 6x4 rectangle, so the entire area is 24 of the whole rectangle. Then I can remove the extra pieces. So find the area of this pink triangle and take it out. Find the area of this blue triangle and take it out, and find the yellow and take it out, and it will leave the area of the green triangle, which is what I wanted. So that's what we've done here. this is a right triangle, so we can use this as the base and the height. And so we did 1/2 times 6 times 3 for the pink one, and then for the blue one here, and then for the yellow one. So again, just subtract all of those from the original 24, and it will leave you the area that you need. I'm just going to leave it there because I think you got the idea. All right.